Hello everyone, myself Piyush Kumar Garg. I am here to present my paper EnDSUM, Entropy and the Diversity-Based Disaster Tweet Summarization. These are the outlines of my presentation. Introduction. First, I discussed that why we need that the disaster tweet summarization. During a disaster, either the natural or the man-made disaster, the eyewitnesses and the other support personnel are posted a large number of situational tweets on the social media platforms such as the Twitter. The situational tweets contain the information about the various needs of the affected pupils located in the disasters areas, such as the flood and water needs, shelter needs, some information about the infrastructure damage, donations, medical emergencies of the affected pupils, and so on. So the humanitarian organization and the local administration rely on the social media platforms to search that the useful information for the disaster response. The volunteers and the other support personnel generate the report or the uh, summaries to address the different needs or various needs of the people located into the disasters area. Existing literatures find out that the extractive disaster to summarization approaches are classified into the supervised and unsupervised based approaches, where the supervised based approaches require that the human intervention and the large training data to generate a summary, whereas the unsupervised based approaches do not require any human intervention to create the summary. And therefore, and further, the unsupervised based approaches are classified into the content based approaches, graph based approaches, and the ontology based approaches. And the supervised based approaches are classified into the deep learning based approaches. Existing content-based approaches explore the high variance in the frequency and the presence of the tweets, or presence of the tweet keywords related to a disaster to generate a summary. These approaches determine that the importance of each tweet by the calculating the importance of the each keywords of that tweet. The importance of a keyword is calculated based on the frequency-based approaches such as the LUHN, some basic, and the TF-IDF based methods. After that, they select that the after that they select that the highest importance tweets to generate a summary. However, the content-based approaches having some limitations these approaches uh, currently dep- currently consider the content-based information to calculate the importance of the each tweets, and these approaches ignore the important contextual information to calculate that the tweet importance. These content-based approaches do not consider the information diversity of the tweet keywords to generate a summary, and as they consider only the highest important tweet into the summary, and they do not ensure that the coverage of the that frequent keywords in the summary. Uh, that's a possibility. Uh, it's a possible that the less frequent keywords contains that the higher contains that the main aspects of the disaster. So existing graph-based approaches consider existing graph-based approaches initially create that the two similarity graph where the nodes represent that the tweets and the edge represent that the similarity between them. Uh, this similarity is calculated based on the content information between the tweets, and after that they identify that the different groups or the categories present in that the tweet based on the community based identification approaches. Uh, and finally, they create a summary by selecting the representative tweet from each category into the summary. How these graph-based approaches having some limitations, like these approaches uh, rely on the community-based approaches to identify that the group or categories, which is very challenging due to the high vocabulary overlap across that the categories. And also these approaches gives that equally importance to the each categories while they selecting that the tweets into the summary. And these approaches do not explicitly ensure that the diversity in the summary diversity in the summary. So the ontology-based approaches initially determine that the category of each tweet, and then they determine that the importance of the each category with respect to the given disasters, and then and finally they selected the representative tweets from each category to create a summary. However, these ontology based approaches rely on only on the identify that the categories which lead to the incorrect summary if they do not identify that the categories properly, two categories properly. So the supervised based approaches, the deep learning based approaches explore explore the content and the contextual information of the tweets to determine that the importance of the each tweets. They capture the semantic meaning of that tweet to calculate the tweet importance. And finally, they based on the tweet importance, they select that the higher important tweet into the summary. However, these approaches does not consider that the tweet keyword diversity while they creating the summary. Motivation from literatures we have seen that the none of these approaches try to handle that the keyword diversity while they selecting the tweets into the summary. Another motivation is that the existing approaches really of the identifying that the category initially to create that the summary, and which may lead to the incorrect summary if the category identification is wrong, yeah, or the categories are not identified properly. So the problem formulation, they given a disaster event E that comprises of a set of M tweets T represented by the T1, T2, T3 and T1, T2, T3 and Tm. We aim to create the L length summary where the summary as that is the subset of the given tweet T in a way that the summary tweets contains summary tweets provide that the maximum information coverage and the diversity while they stating in the summary where the information coverage, what is the mean of the information coverage? The information coverage uh, ensures that the summary tweets will cover some summary tweets should cover that the all the main aspects of the uh, given the tweets, and the diversity ensures that the no tweets in the summary contains the similar information. So we propose and the entropy and the diversity based disaster to summarization approaches that that input of that our approaches that is related to disaster event, then we pre-process then we apply some pre-processing to the input tweets like as a stemming, lemmatization, and we remove that the word with the less than three words, and we also remove that it to specific keywords as we consider as it only the tweets, such as the we remove that the hashtags, we remove that the user mentions, and URLs also, and then we calculate that the in entropy scores of the each tweet and the diversity scores of the each tweet. Then we calculate that the combined score of the each tweet by combining that the entropy and the diversity based scores. And then finally uh, and then finally we uh, and then finally for each iteration we select that the highest uh, important twist based on that the combined scores into the summary, and that we repeat that process, this one and this one, the other two process, we repeat that the process that the summary length constraints are not satisfied. And in most of the summarization cases, the summary length is also be provided. So here we calculate that the entropy scores. We calculate that the information coverage score as a entropy scores, and there are the several approaches present that the calculating the entropy scores of the each tweets. We rely on the Kasi entropy that can resolve that the inherent vocabulary diversity issue that actually that one of our motivation is that so after that after that we calculated the entropy score of the each tweet ti by considering the similarity of the ti with the other tweets, as the e of ti comma k is the summation of the minus of p of ij power of gamma, a log of p of ij, where the k represent that the list of the similar tweets with respect to the ti, and the gamma represents that the importance of the similarity, where that the pij is the probability of the tweet, this is the probability of that the tweet ti, and the tj which is calculated based on the number of overlapping keywords between the tweet ti and the tj divided by the total number of the keywords, um, uh, total number of overlapping keywords from the TI to the kth kth list, uh, the tweets in the kth list. So, the diversity scores that we calculated the diversity scores of the each tweet TI by the uh, by which measures that the diversity with respect to the already generated summary as test that which we calculated the 1 minus ti of ti and the s test, similarity of the tweet TI with respect to the already generated summary S test, we calculated by summation of the K belongs to S test, the overlapping keywords between the TI and the tweet with the TK divided by the length of the TI. After that we take that the weighted weighted we take that the weighted combination of these two scores to generate a final scores of the each tweet, to the given the tweets, given all the tweets. So here, for the weighted sum, we consider that the alpha and the, beta as the uh, equally importance to both the entropy and the diversity. And for the each iteration, we select a tweet that has that the maximum scores based on this equation. For the we repeat this process till our summary length is uh, till we generate that is L length tweets. That is our summary length. For the experiment, we use that the six data sets that that belong that that is different that is the man-made and the in natural data sets, natural disaster data sets. And these data sets are belong to the different country and the different continents. And these data sets are created between the 2012 to 2013. Okay, baselines to compare that the our proposed approach and the sum. We use that the four baselines that these baselines that based on the content based, graph based approaches, ontology based approaches. Uh, uh, So to evaluate our proposed approach, we use that the huge scores like recall oriented understanding for the gifting evaluations. For the F, we consider here that the root 1, root 2, and the root L. F1 scores for the our comparison, where that is root 1, the one represents as a unigram. While we are calculating the root score, we compare that is unigram overlap between the our summary generated and that the ground truth summaries. And the two represented the bigrams, and the L represents here that is the longest common subsequences message. On the experimental results, we have seen to compare our proposed approaches with the different baselines using the root one, root two, and the root L scores. We For the six data sets, we have find that the our proposed approaches is giving the higher performance in the most of the cases, like that D1, the D4, D5, and the D6. um, uh, so the conclusion is that uh, we propose as a novel entropy and the disaster to its summarization approaches like the EnDSUM that provide that the maximum coverage of maximum coverage of the information by selecting that the higher entropy tweets into the summary. And also simultaneously that the our approaches EnDSUM provide that the provided the maximum diversity in the summary by selecting the higher diversity score tweets into the summary. And our proposed approaches do not require the identification of the any groups or categories to create the summary. And we showed that our proposed approaches and the sum uh, with the different baselines that on the six disaster events that indicate that the high performance we obtained of our proposed approaches in terms of the do's and scores. So that the future works, um, we have seen we now currently we now consider only the content based information while we can calculating the entropy and the diversity score while we calculating the entropy scores, entropy and diversity scores. In future we try to include that semantic and the contextual similarity while we calculating the diversity and the entropy scores. uh, Another is that we extend our proposed approaches and DSUM in a way that it provides that the complete information coverage while the disaster event by automatically obtaining the without predefined summary length. As our proposed approaches. While we producing the summary, we require that we should provide the summary length L. In future, we did not we design or we modify our proposed approach in a way that we do not require any summary length for to generate the summary. And another and the last and the future and the last future work is that we we modify our proposed approach such that it can select that the best subset to it simultaneously as the summary um, uh, and now we consider that the each iteration we select that the higher score tweets into the summary to into the summary and into the summary for the each iteration actually. So we try to modify our approach in future that we can select at the time we can select together that the L and tweets into the summary. These are the references of my presentation. Okay. Thank you for your attention. If you have any query, you can ask them.